All right, today we're going to be talking about the rest of section 2.7, linear inequalities. Let's go to work. Quick little refresher before we get into it, okay? Looking at the inequality signs, we have greater than and less than. Okay, these are the first two. And depending on what we're dealing with, like yesterday's homework, we dealt with an open bubble or a closed bubble, right? We talked about it in class being whether it included or not. If you're talking about interval notation, if it was greater than or less than, you used a parenthesis. And today we're going to talk about two variable linear inequalities. So we'll end up with lines that are dotted or solid. So down here, when we talk about greater than or equal to or less than, remember, just a reminder, if I'm writing stuff down, you should be too. Less than or equal to, that was inclusive. It includes the number. So we had a closed circle, we had brackets, and or we'll have a straight line. Okay. So yesterday we dealt with one variable linear inequalities, and if we only had one variable, we graphed our solutions on a number line. Today we're going to have two variable linear inequalities, which means we will graph our solutions on coordinate planes or two number lines. Now, I hope that you'll enjoy this and realize that we really already know how to do this with one simple addition or two simple additions. So let's look at number one that I have here for you as an example. Notice that is in slope-intercept form. Remember, y equals mx plus b, or according to our video that we like so much, get the y alone, right? The y is already alone in this case, so I can graph it simply. What is my initial value? It is a -2, so I plot that, my initial value or my y-intercept. And then I look at my slope, which is always in front of the variable. In this case, it's a -4. So from that point, I go down 4, 1, 2, 3, 4, and right 1. Or I could have went up 4, 1, 2, 3, 4, and left 1. Okay. So far, same, right? Same what we've been dealing with. Now, I'm about to connect the dots with a line. But now I got to determine, is that line going to be solid or dotted? So I look at the inequality. And since I see that it is a or equal to, that tells me it's going to be a solid line. So far, so good. See a lot of nodding heads. That's good. Now, please, like literally at your computer, put your pencil on the y-intercept. Okay, put your pencil on the y-intercept and hold it there. While you're holding it there, I have you put your pencil on that because I only want you to think about the y-axis. Don't think about anything else, just the y-axis. Okay, and from your pencil, I want you to think about greater than. Where would that be? Above, right? So that's where we shade, above. If I had said less than, we would shade below. Pretty simple. All I did was read the sign. Can you handle that? Now, why did I shade that area? Because every point in that whole area, on that whole side of the line, is a solution. If I would plug any of those numbers or coordinates into that equation, it would work. I'm going to give you an example just for fun. Let's take this lovely point. Let me go to a different color so you can see it well. There's a purple. Let's take that lovely point right there, which is the point 3, 3. Watch what happens when I plug it into that equation. 3 is greater than or equal to, -4 times 3 minus 2. 3 is greater than or equal to -12 minus 2 is 3 greater than or equal to -14. Yes. And every point on that side of the line would do the same thing. It'll give me a solution. And that's why we shade it. Because there's an infinite number of solutions. I mean, heck, we thought there was a lot when there was just a line, right? Now we got to shade a whole side of the line because there's even more. How do you get more than infinity? That'll blow your mind, right? You guys remember you were in kindergarten. I love you, infinity. I love you, infinity plus 1. All right. Let's try number 2. Let's try number 2. Oh, we're just having a blast today. All right, what's my y-intercept? 0. It's not there, is it? Plus 0. So it's my y-intercept 0. What's my slope? -4. So I'm going to go down 4, right 1. Or I could have went up 4, left 1. What kind of line am I going to have? Solid or dotted? Dotted. Dotted. Why is it dotted? Because it's just greater than. There's no or equal to. If there's an or equal to, it's solid. If there's no or equal to, it's dotted. All right, put your pencil on the y-intercept and read the sign. Greater than. So, above. Simple enough? Think you can handle it? You do a couple more just quickly. Oops, undo. Let's go. Let's do number 4 here. Y-intercept? 2. Slope? Down 7. 1, 2, 3, 4, 5, 6, 7. Over 4. 1, 2, 3, 4. Or right 4, I guess. Solid or dotted? Dotted. Put my point on the y-intercept and read the sign. What's that sign say? Greater than. Any of us struggle on which one's which, greater than or less than? If you do, the only thing that took me forever was, you got greater than and you got less than. Oh, it's an L. That's not an L. That's an L. That's when I first learned greater than, less than. It took me a while before I knew which one was which. Just throwing that out if you can't read the sign. All right, so that seems to be pretty easy, yeah? One more. We're just flying here, right, Tristan? Y-intercept? Thank you, Tristan. -3. Slope? Tristan? 5. Up 5. 1, 2, 3, 4, 5. Over 1. Solid or dotted? Don't everybody speak at once. Solid or dotted? Dotted. Okay. Pencil on the y-intercept. Read the sign. What's it say? Less than, so below. Okay. Cool. All right, so what happens if we have an equation like these, where all of a sudden they're not in slope-intercept form? Oh no, whatever will I do? I'll get the y alone. I can do that, can't I? Sure. So on this number 11, I would subtract 8x from both sides. So I'd end up with y is greater than -8x plus 5. Now it's in slope-intercept form, right? Now, the same thing. Once I start manipulating these equations, if I ever multiply or divide by a negative, I'll have to flip the sign, right? Did I have to do that here? No, I just subtracted 8. I didn't multiply or divide. But I'm done. My y-intercept is 5. Down 8 over 1. Line is dotted. And sign says greater than, so above the y-intercept. Cool? Let's try number 16 here. Okay, I got to manipulate it. I got to get that y alone. So I got to start by subtracting 7x from both sides. So I end up with a -2y equals a -7x minus 8. Sorry, not equals. That sign is greater than or equal to. Okay. Now what? Divide by -2. Divide by -2. You hear it? Do you hear it? There it is. There's that siren going off in your head. You divide it by negative. Got to flip that sign. So 7/2 x plus 4. Y-intercept? 4. Up 7. Oops, that goes off the graph. So I could also go down 7 and left 2, right? So down 7. 1, 2, 3, 4, 5, 6, 7, and left 2. Dotted or solid? It's or equal to, so it's solid. And then I finish with reading the sign. My new sign says less than. So I shade below. Excellent. Questions, comments, concerns? Homework is 13 through 24, all of them. 2-7, 13 through 24, all of them. Have a great day.